In this video, I would like to go over two examples involving Bernoulli trials, otherwise known as binomial probability distribution. Here we go. We have 12 jurors are to be randomly selected from a population in which 80% of the jurors are Mexican American. If we assume the jurors are randomly selected without bias, and if we let our random variable x represent the number of jurors in among 12 selected, we will get a probability distribution represented by the following table. Okay, so we already have a table with calculated probabilities and also a corresponding histogram. There they are. So we're going to answer these questions. Find the probability that there are at most 5 Mexican American jurors among 12. Okay, so at most 5, that means we're looking for the probability that at most 5 or less. So that's going to be x is less or equal to 5. Okay, on this, if we're looking at the histogram, 5 or less is right here, 5, 4, and so very small values. That's what we expect here on the table, 5 or less. That's going to be here. So see these zeros with pluses, says there is some probability, but the probabilities are really, really small. They're very close to 0. So we're going to have 0 plus 0 plus 0 plus 0. I'm not going to write them down. Plus 0.001 plus probability of 5 Mexican American jurors is 0.003. So altogether, that probability comes out to be 0.004. All right. So next, we're looking for the probability that there are more than half Mexican American jurors among 12. So more than half, let's think about it. If we're looking at 12 jurors, 6 is half. More than half means more than 6, right? So the probability that there will be more than 6, actually it's the same as the probability of 7 or more, so greater or equal to 7. And that probability is right here. So that event is here, 7 or more. It's 7 or 8 or 9 or 10 or 11 or 12. So we would be adding all of these probabilities together. So what do we have?
We have 0.053 plus 0.133 plus 0.236 plus 0.283 plus 0.206 and plus 0.069. By the way, I would like you to try and do it by yourself before I show you how to do it, so this way you learn better.
And I got 0.98 for those probabilities. Okay, let's take a look at the next question. The next question is, there are between 9 and 11 Mexican American jurors among 12. Okay, so we're looking for the probability that our random variable, the number of successes that we have, is between 9 and 11. So let's see, between 9 and 11, that's going to be this event right here, 9 and 11. So we're going to be adding 3 corresponding probabilities.
0.236 plus 0.283 plus 0.206. All right, so again, let's add them up.
And I got the probability of 0.725. Okay. The next question is to find the mean and standard deviation for this distribution. Let's do that. So the mean is gonna be n times p, right? So n is 12. P is probability of success. We said there was 80% of Mexican American jurors, so that's our probability of success of selecting someone who is Mexican American. Okay, so let's put it in a calculator. 12 times 0.8 gives me 9.6. 9.6. So let's stop here and think about what 9.6 represents. Remember, for our probability distributions, mean is also the expected value. The expected value. So what that means is that if we have population with 80% Mexican Americans, then among 12, we expect 9 to 10 be Mexican Americans. Let's calculate the standard deviation. So the standard deviation is the square root of n times p times q. So it's going to be the square root of 12 times 0.8 times 0.2, because that's what the complement, the probability, the complement of 0.8 is. So it is 1.39, about, rounded to 2 decimal places. Now, what does it give us? Well, now we can find the minimum and maximum usual values. Remember, we said we have our expected value in the middle. And then the minimum usual would be mean or expected value, 9.6 minus 2 standard deviations. And the maximum expected would be mean plus 2 standard deviations. And those values are 6.82 and 12.38. So we found the probability of it to be 0.004. What that means. So this is the minimum usual. I hope you see that so we can expect value, the number of Mexican American jurors among 12 to be a number between 6.82 and 12.38. So our usual values, basically more than 6, unusual values, and will have all the way up to 12, right? So if we got a jury that had only less than 5 below. Now, is this Mexican American abnormal value? Would that be unusual? Good question. Let's see. So let's find the abnormal value. Abnormal value would be even one more standard deviation, to this side and one to that side. But we're going to find only one, the bottom one. So that would be 6.82 minus 1 standard deviation. And that value is 5.43. Anything lower than 5.43 would be abnormal. So here, if we have the number of successes less than 5, that's an abnormal value. And I'll make the same conclusion from the probability that we see. This probability is very low. So yes, it is abnormal. And this is it for this example. And we're going to do one more.